So now let's look at tangent and cotangent. What makes these different is because of the period. The period of tangent is just pi. The range is from negative infinity to positive infinity. Same thing for the cotangent. And that is because tangent, remember, of theta was defined by y over x, and x can't equal to 0, which means you get an undefined here. So tangent is undefined at different places. Now where is it undefined? Well, it's undefined when x is 0. So as you look at your unit circle, when are your x values 0? Well, they're equal to 0 at pi over 2 and 3 pi over 2, or we could call that negative pi over 2. So between negative pi over 2 and positive pi over 2, these are all our tangent values. Right? So as x is changing, gives us here, and so we have some negative and positive, and it repeats itself every pi. So I'm going to choose convenient from negative pi to positive pi over 2. And remember, this is when x is 0, so we have asymptotes. When we have this at 0, tangent is y over x. Well, the y value is 0, the x is 1, so we get a tangent value of 0. Right there at 45 degrees or pi over 2, the x and y is the same, so you get a tangent value of 1. And I'm going to call this 1, 2. So at pi over 4 we have 1. So we have this graph that looks like this. It's approaching the asymptote. And then down here at negative pi over 4 we have a value of negative 1. And that's what your tangent graph should somewhat look like. All right. It fits it between two asymptotes. You get the whole idea of the tangent graph, all the positive and all the negative values. And again, that period is pi. But cotangent, now cotangent was defined, the cotangent of theta was defined to be x over y. So we need to know when y is 0. Well, at the opposite values. So we're going to have asymptotes at 0 and pi. And in like manner, the cotangent is equal to 0 at pi over 2. I'll call that 1 and negative 1. The cotangent of pi over 4 is positive 1, and 3 over 4 pi is negative 1. So you should get a graph that looks something like that. So they're kind of mirror images, they're also shifted. So we have asymptotes here at 0 and pi, asymptotes here at negative pi over 2 and positive pi over 2. So when we're graphing the tangent, we don't really have an amplitude because it grows, but we're going to call that distance here the A value. Right? So the quasi-amplitude. The vertical shift is still D. We're not going to talk about the phase shift here, but the period is going to be not 2 pi, but pi divided by B. And you need to remember where you're going to begin and end. You want to fit those graphs between two asymptotes. That's my rule. So we have graphing the tangent graph here over one period interval. So, and again, my quasi-amplitude is 1/2, so it's a little bit squattier. The vertical shift is up 2. And I'm going to do just like I did on my sine and cosine graphs, except here, what am I going to fit it between? Not 0 and 2 pi, that wasn't my original. Not 0 and pi, that wasn't my original. My original graph were between those two asymptotes. That's what I'm going to do. So I'm going to add pi over 3 and get negative pi over 6 and positive 5 pi over 6. I'm going to divide everything by 2. And how this helps me is I know this is where an asymptote is, this is where an asymptote is, that's that beginning and end. So I'm going to take my horizontal axis and I'm going to label those. I'm going to have those same 5 tick marks. I need to find the middle. So again, I add -1/12, +5/12, that's 4/12. Take half as 2/12, otherwise known as 1/6. Calculator may come in handy. Just leave out the pies, just leave your fractions. So this is -1/12 plus 1/6, which was 2/12. 2/12 and a -1/12 is 1/12 divided by 2 is 1/24. Ugh, yucky. In like manner, you're going to get this to be 7/24. Again, I'm just going to put a vertical axis. Notice I'm not putting it at 0. It's harder to label it that way for me. Okay, so since it was shifted up from 0 at 2, I know this starts at 2, and then I'm going to go up a half and down a half. So what this tells me is that my key points fit between those boundaries and those boundaries. So I know this is an asymptote, this is an asymptote, the tangent in the middle is at 0. Then the question does it go up or down? That's just something you need to memorize, but the tangent goes up here, down here, and looks something like that. Let's do a cotangent. All right, so again, our amplitude is 2, our vertical shift is down 1, and I'm going to take the angle, and again this is my way, and I'm going to set it between what two values? Where did my original cotangent begin and end? What were the asymptotes? They were at 0 and pi. That's the tricky part. You've got to just memorize that. So I'm going to subtract pi over 4. Then I'm going down, look, that's interesting. So I'm going to multiply, I need to get x by itself. I'm going to multiply by 2 over pi. All right, so that's going to cancel all that out. That's going to cancel out the pi's. I'm going to reduce that to just 1/2. And I'm going to reduce this to 3/2. The pi's went away. We're still in radians, right? Not in degrees. So again, this is my beginning. This is my end. So take that horizontal axis. What's in between there? It'll be positive 1/2 here, 0, and 1. Then I'm just going to have my vertical. My vertical shift is at -1, so the middle of my graph is at -1. I need to go up 2 from there and down 2 and label that. And again, those are where my asymptotes are. And then the middle is always going to be 0 along your horizontal shifted axis. Remember, it shifted it down 1. And then where does your cotangent? Well, it's going to come back 2 above your horizontal axis and 2 below your horizontal axis. Again, I want to emphasize there are many ways to get to these numbers, how you've memorized to graph it. Any way you get there, as long as it's not cheating, I'm okay with. And as long as your graph has the top, middle, bottom, and those 5 equally spaced tick marks that your tangent and cotangent are between two asymptotes.